Here's a trigonometric revision for those of you who will be writing your supplementary exam for mathematics paper 2 this upcoming Monday. If you can listen to this video until the very end, I want to answer most, let me just say, a little bit complicated questions for functions that actually comes with a lot of marks. So if you can know this, by Monday, trigonometry will not be such a problem to you. Well, we have started a program called the Exam Focus. It is going to help you prepare for your June exam, your trial exam, as well as your final examination. To those who are making the right moves of joining it, come January, they will be celebrating with their families. Well, let's actually get down to these questions. I want us to do them. They say we are given the sine of beta that equals to 1/3, and this actually ranges, the value of beta actually ranges from 90 degrees until 270 degrees. And now they say without using a calculator, we need to find the cos of beta, sine of 2 beta, and the cos of 2 beta. So each and every single time you are given a statement and you are given a range, although sometimes they will not necessarily give you a range, but whenever you are given a statement like this, you need to know that the first thing that you do is to draw a diagram. So this is the kind of diagram you should draw. The diagram should look something like this. Now, we all know that this is 0 degrees. This is going to be a 90 degrees, 180 degrees, as well as 270 degrees. We don't have to go to 360. So they say that the value of beta ranges from 90 degrees. So it starts from 90 degrees until 270 degrees. How do we plot our diagram? Well, the sine of beta is a positive. So it means that the way we plot our diagram, within the diagram, the sine of beta should be positive. And how do we do that? How do we make the sine of beta to be positive? Well, we can only plot the diagram on this quadrant or maybe on this quadrant. We cannot plot it on this quadrant and this quadrant because the value of beta starts from 90 degrees. This is a 90 degrees until 270 degrees. So it starts from 90 degrees until 270 degrees. But between these two quadrants, which one are we going to draw it from? Well, I prefer we just do a trial. Let's start within this quadrant. Let's say we want to draw it here. Right? So let's just make this to be some sort of a right angle triangle. So if we draw the quadrant here, we know that sine of beta, it is opposite, and the opposite is 1, and the hypotenuse is going to be 3. So if we draw our diagram on this quadrant, the sine of beta remains positive because this value of 1 is positive. But let's say you made a mistake. Let's say you drew the quadrant, you drew this structure on this quadrant. What would happen if you drew it in this quadrant? The opposite will become -1 because this is actually minus. You know, everything downwards is a minus. There's going to be a hypotenuse of 3. So because this one is a minus, it means that the sine of beta would be -1 divided by 3. And it is not the original statement. So you immediately know that you have made a mistake. So your quadrant should, so from the diagram, the sine of beta should remain positive. So that is why the correct answer, it is actually on the second quadrant. Now, what is left? You realize that you have the value of y, you have the value of r, but you do not have the value of x. So you need to find the value of x. How do you find the value of x? You use the theorem of Pythagoras to find the value of x. So it's going to be r squared equals to x squared plus y squared. We know this phenomenon to be the theorem of Pythagoras. And the r squared is going to be 3. Okay, this slide is too much at this point. And then the x squared, it is what we are looking for. And then the y squared, it's going to be 1 squared. So this becomes 9 equals to x squared plus 1. When we take this to the other side, we'll have 8 equals to x squared. Sorry guys, my light is just brightening too much. Okay, so what is the square root of 8? the square root of 8 becomes 2 the root of 2. So it means that the value of x, it is 2 root of 2. So it means that we are having this diagram with beta, with x being 2 root of 2, with y being 1, hypotenuse being 3. So now we are being asked to find the cos of beta. From the diagram, what is the cos of beta? So you're going to say, well, I know that the cos of beta, it is x divided by r. It is adjacent over hypotenuse. What is the value of x? It is going to be 2 root of 2 divided by 3. Well, which sign is the value of x from the diagram? Obviously, x has to be a negative. So it means that this x is a negative. Even on this diagram, the x has to be a negative. So it means that the cos of beta also has to be a negative. Now, the second question, they want us to find the sine of 2 beta. Well, what is the sine of 2 beta? The sine of 2 beta is actually an trigonometric identity. So we know it equals to 2 the sine of beta, the cos of beta. Well, you don't have to use the diagram for this one because we already know sine and we already know cos. So we have to. What is sine? Well, sine is given from the original statement. So sine, it is 1/3. So you are just going to use 1/3. Even if you were to use the diagram, the sine will be opposite divided by the hypotenuse. So it is 1 divided by 3. And this is what we have. So the cos of beta, we have just found it. We have just found the cos of beta to be minus 2 root of 2 divided by 3. So it actually becomes your answer. This is your cos of beta. So this becomes your sine 2 beta. This is your solution. Let's look at the final one. We're having the cos of 2 beta on the final round. We're having this cos of 2 beta, the cos of 2 beta. So cos of 2 beta is a trigonometric identity that have 3 identities. You can either turn it to be the cos squared of beta minus the sine squared of beta. You can turn it to be 1 minus 2 sine squared of beta, or it can be 2 cos squared of beta minus 1. So you can use any trigonometric identity you like to find the values. Let's just use this one of sine. I just love it for some reason. So it means it's going to be 1 minus 2. What is sine? We already know that sine is 1/3 divided, to the square. So it's going to be 1 minus 2, 1 divided by 9. So you can just leave your answer to this point. That becomes your final answer. So that's how you actually do this type of questions. So let this one be part 1. And then I am again going to post, finding the solution for part 2. In fact, we still have some time. Let me just do it. I think we still have time. Let's just do part 2 of it. How can we actually, by the way, we still have got these questions. So I want to answer all the major questions for you guys to prepare for your June examination so you can do extremely great. Now, they say we are given that the root of 13, the sine of x plus 3 equals to that. So if I'm having the root of 13, the sine of x plus 3 equals to 0. Let me just change my pen. We need to make the sine of x subject of the equation. So I know I'm having the root of 13, the sine of x equals to minus 3. So I'm going to divide both sides by the sine of x by the root of 13. So this becomes my statement. Now I need to draw a diagram. And this diagram needs to start at 90 degrees until 270 degrees. So this is 90 degrees and this is going to be 270 degrees. So the value of sine is a negative. So remember, whenever the value of sine is a negative, we have saw from the previous video, this is the quadrant we use. So we don't have to think about that. We know the diagram has to be here. So that the x would be minus 3 and the hypotenuse would be the root of 13. Now we need to find the value of x using the theorem of Pythagoras. And we know that this is going to be the square root of 13 squared. We want to find x plus 3 squared, and the 3 is minus. So it's just going to be 13 equals to x squared plus 9. So what is 13 minus 9? It's going to be 4, and the square root of 4 is just 2. At this point, it's going to be minus 2 because this answer is actually on the negative quadrant. Now, the value of x, what they were trying to find us? They say we need to find sine 360 degrees plus x. We need to find the sine of 360 degrees plus x. A lot of people use the cos table. I do not prefer it. You don't have to use the cos table at this point. What do you prefer you should do? You are just going to say the sine, whenever there is x, you are just going to put 60 degrees to see whether you get a positive or a negative answer. If you get a positive answer, it means that the value of sine is positive. If you get a negative answer, it means that the value of sine is a negative. So we're going to say, well, the sine of 360 degrees minus, this is, it's plus. So we're going to have the plus of 60 degrees. We get a positive root 3 over 2. So it means that the sine of x is going to be a positive. What is sine of x? You don't have to use your calculator. You don't have to use the diagram. We did find the sine of x. Yes, the sine of x. Even if you use your diagram, the sine of x is still going to be minus 3, the root of 13. So that's how you were supposed to find this question. Let's actually look at this one of tan of x. How can we find the tan of x? Well, we know that the tan of x is opposite divided by the adjacent. At this point, the opposite is going to be minus 3. So it's going to be minus 3 divided by the adjacent is going to be minus 2. So the answer just tends to be 3 divided by 2 because these negatives are just going to cancel out. Now, we have the cos of 180 degrees plus x. How do you do it? You are having the cos of 180 degrees plus x. You do the very same thing that I have done. You're going to say the cos of 180 degrees plus 60 degrees. What do you get? You find a negative answer. So it means that the cos of x is just going to be minus the cos of x. And then you go to your diagram. How do you find the cos of x? So the cos of x is going to be adjacent over the hypotenuse. So you already have a minus, this minus divided by, you are having minus 2, yes, the minus 2 divided by the square root of 13. So your answer becomes 2 root of 13 because this negative and this negative are actually going to cancel out. Now, let's look at this question for the last 1 minute that's actually remaining. They want us to find the value of this question. Well, let me just do it quick. 1 minute is left. Let's draw it. We're actually having the sine of 2x. What is the cos of minus x? So the cos of minus 60, it is going to give us a positive answer. So we have the cos of x. Let's not write the sine yet because I see this. So we're going to have the cos of 2x. So the sine of 360 degrees minus x is going to give us a negative answer. So it's going to be the sine of x. So it means that this becomes a negative and it is all divided by the sine of 180 degrees is going to be minus the sine of x. Now, this becomes a trigonometric identity. So we know we're having 2x and we're having 2x and x. This looks similar. This is the same as the sine of 2x minus x. If you expand this, it will just take you back here. So it's important for you to also look at what's happening on your diagram when you're solving these questions. And then you divided everything with minus the sine of x. So 2x minus x is the same as the sine of x divided minus the sine of x. Now sine of x divided by minus sine of x, it just becomes minus 1. So that's how you solve it. So on the next video, I will be solving these next questions.